ChatGPT sucks at addition and like multiplication and division and so on, at arithmetic. And in general, it kind of sucks in, at solving algorithmic tasks. And here the question I try to address is, can we just teach like large language models to use algorithms, like for doing multiplications, divisions, like reasoning, planning, scheduling, and all that? The problem is, how do we, like, one problem is why we may want to do that. So why, what can we get by having hybrid models composed by symbolic algorithms and neural nets? Why we may want to do this? One reason we may want to do this is that we may want to incorporate, for example, a planning algorithm, like a shortest path algorithm in our model, to make the model able to solve complex tasks that require some degree of planning or reasoning. And another reason is that by having discrete symbolic latent representations in our model, for example, if we have, for example, hard attention distributions, we may be able to have more explainable neural models. So for example, one motivating example is learning to plan. In this setting, the input is a map in the form of pixels. Then a neural net assigns some continuous weights to each cell in this map. Then those weights are used to produce, are fed into a shortest path algorithm, which produces a discrete path, for example, the shortest path from one point to the map to the other point of the map, which is then used to take a decision, for example, whether to turn left or right. So for example, it can be a self-driving car that has a map of the area, and this self-driving car, maybe it might need to have some shortest path algorithm to reason over the map. The problem is that the map is in pixels, is not as a graph. And so basically the model needs to turn the map into a graph that can feed into a shortest path algorithm. And then it needs to use the shortest path algorithm to decide, for example, whether to turn left or to turn right. And the question here is, how do we backpropagate through this discrete component here that, given, for example, the cost of traversing each cell in the map, gives you the shortest path? How do we backprop through this?